Hi friends, welcome back. Today we are going to solve another very recent and popular Leetcode coding interview question 2592, maximize greatness of an array. So this is another popular recent medium complexity array related coding interview question that we are going to go through today. We are going to understand this problem with some examples, and we are also going to implement our Java solution code to solve this coding problem. If you are new to this channel, please subscribe to this channel now. Also, click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, logic building, programming and coding. So let's start. You are given a zero indexed integer array nums. You are allowed to permute nums into a new array perm of your choosing. We define the greatness of nums to be number of indices 0 is less than equal to I is less than nums dot length, for which perm of I is greater than nums of I. Return the maximum possible greatness you can achieve after permuting nums. Okay, so this is what the problem says. So nums dot length is between 1 to 1 lakh. So maximum 1 lakh numbers will be there in the given array, and the number itself will range between 0 to 10 raised to 9 inclusive, right? So let's understand this problem better with some examples. So basically they are saying that we can do the permutation of the given numbers in the array. We can create a new array, we'll call it as a perm array, and the greatness of the array is perm I should be greater than nums I, right? So maximum number of values we have to find like this so that we can get perm I is greater than nums of I, that is the greatness of the array, right? So we want to maximize that greatness, correct? So this is one example. So here you have this nums array 1352 131, correct? So they have done a permutation like this. So this is our original array, right? 1352 131, correct? 131. So this is the original array that we have. Now we have done a permutation, what they are saying. So you have done a permutation 25133 here and 1 1, correct? So this is the permutation because you just place these elements in a different position. So one came here, this one came here, this one came here, like this, right? Okay, now what the perm greatness means is that this new array value should be more than its corresponding value. So 2 is more than 1, right? So it will be counted 1, like greatness. Let's say we write a greatness here, right? Greatness value. So it is initially 0. So now we'll say one greatness value we found at this index, right? Because 2 is more than 1. Second value we found out for this index because 5 is more than 3, right? Okay, then third value we found out at this index 2 is 3 is greater than 2, so greatness value became 3. And the fourth value we found out as at this index where 3 is greater than 1, so greatness value became 4, right? Now this is not contributing to greatness because 1 is not greater than 3, 1 is not greater than 1, 1 is not greater than 5. So we only found 4 such indexes where the perm of I is greater than nums of I, correct? Perm of I is greater than nums of I. So the greatness value we found out 4. This is the maximum value we can get. That's what they are saying, and that's what we want to find out, the maximum greatness of an array. Okay, so now you understood what the problem is saying with this example, right? So we want to rearrange those numbers so that we can maximize that greatness value. Okay, so now the problem statement is clear with this example for you. So how can we approach and solve this problem? To maximize this greatness value, what we can do is we will take all these numbers, right? We'll take all these numbers in the given nums array, and we will add these numbers into two priority queues. We will use a min heap here, min heap. Okay, we'll use a min heap. So let's say we created two priority queues, right? The first priority queue and the second priority queue, right? So I have two priority queue created and I added all these numbers into priority queue. This is a min heap, right? So how the elements will be sorted minimum first, so you will have 1 1 1 in the beginning, then 2 3 3, right, 2 3 3, and then 5, correct. So 1 2 3 4 5 6 7, right. Okay, so same thing you will have for the other priority queue as well, right. Both priority queue will have same numbers now, because both are min heaps. Okay, 3 3 5. Now what we will do after that is we will start like checking if the priority queue 1 element is smaller than priority queue element, priority 2 element. So is this one smaller than 1? No, right. So it's not smaller, so we will remove the priority queue 2 element, right. And we will also create one counter. Let's say we have a counter, right. Count is 0 in the beginning, right. So this one is not smaller than this one, so we'll remove it from priority queue. We'll go to the next one, right. So right now we are pointing here, this one is not greater than this one, so we will remove this one, right. We'll go to the next one. This one is not greater than this one, so we'll remove this one, right. The count is still 0, right. So this, until this point you are clear, right. So we are checking, so you can pick the priority queue, right. Pick will tell you the top element from priority queue, right. So this is a min heap, right. Min heap will always give you the minimum element from all the numbers, right. Okay, so now when you check the pick on priority queue 2, you will see 2, correct. 2 you will see, because that is the smallest number in all these numbers, right. So you will check if this 2 is greater than 1. Yes, it is greater than 1. It means that we will increment our count. So our count will be 1 now, and we will remove both elements now. We will remove this one as well as these two. You understood, right? Now we have removed both elements from priority queue 1 and priority queue 2. Okay, so this part is clear. Count became 1. Now priority queue will start pointing, priority queue 1 will start pointing here, and priority queue, now you will again check the, you will pick the priority queue 2. So what you will get? 3. So is 3 greater than 1? Yes, 3 is greater than 1. So you will increment the count. So count became 2, right. You remove both the elements from priority queue 1, you remove priority queue 2 also, you remove, correct. Again now priority queue 1 is starting pointing here, right. Okay, now you will check the, you will pick from the priority queue 2. Pick will give you the smallest element from this element. So what is smallest element? 3. So you get 3. Is 3 greater than 1? Yes. So you remove both of them, you will increment the count. Count became 3, right. And then you are pointing here now, right. You are pointing here in priority queue 1. Now you will again check if the pick, like you will pick the priority queue 2, you will get the 5, right. 5 is greater than 2. Yes, then you will remove both these elements, correct. Your count will become 4, right. Count becomes 4. So this part you understood, right. Now you have exhausted priority queue 2. Now there is nothing to check there, it is empty now, right. So this is the point where we have to find out our answer by using the count. Count 4 is the answer basically for us, right. So why does this approach work? This approach works because whenever we are removing this number from both priority queues, it means that we are actually doing a permutation of those numbers, correct. Because when I say that I have a 1 here, when I have 2 here, it means that I can always rearrange them basically, so that I can put the 1 here and 2 like at the same index, correct. So that this condition becomes valid for those elements. Perm I is greater than nums of I, correct. So this PQ1 is pointing to nums of I in this case, and PQ2 is pointing to perm of I, correct. That's why whenever this number from PQ2 becomes more than the PQ1 number, we are counting it, right. It means that we are actually able to successfully rearrange those numbers so that this condition gets satisfied, right. Perm of I is greater than nums of I. That's why we are counting those numbers, correct. You got it, right. That's why this approach works. So this is a priority queue based approach, and we have used a priority queue as a min heap, right? Min heap. So before we go to the implementation, right? So for example, just one time I'll show you. So this, we have seen that this 1 and this 2, right? 2 is becoming more than 1. So I can always put that 1 here. This 1 I can put it at this index so that I can get perm of I is greater than nums of I, correct? You got it, right? That's why we are counting it, okay? So now before we go to the code, I'll quickly show you the priority queue class that we are going to be using today to solve this coding problem. You already understood this logic with this example. So this is the priority queue class. This is located in java.util package. This is another very important Java collections framework class that got introduced in JDK5. It uses generics, correct? So as it reads, unbounded priority queue based on a priority heap. The elements of priority queue are ordered according to their natural ordering. So by default it creates a min heap, right? By default it creates a min heap, okay? Now the important things I wanted to show you here is this thing, these last two lines, right? So they are talking about the time complexities of some of its important methods. So for example, offer, poll, remove and add, these four methods are important frequently used methods of priority queue class. It takes log of n time for these methods, right? So those methods, those four methods are logarithmic in time. The other two methods, remove object and contains object, these two methods are linear in time. So order of n is the time complexity for these two methods. And pick element and size method takes a constant time, right? Okay, so this is the priority queue class. So you can go through this documentation. These are the overloaded constructors of priority queue class. The important methods we often use is add, offer. So this add and offer will add into the priority queue. Pick and poll will give you the head of the queue. The difference between pick method and poll method is that poll will also remove that element from priority queue, right? Poll removes the head of this queue. That is the difference, right? So go through this documentation. So this is the class we will be using today as a min heap to solve this coding problem. So I wanted to show you a quick documentation. It is located in java.util package. This is another popular collections framework class, right? So now you understood this logic. So let's implement the same logic using Java here. So we are implementing maximize greatness method. Nums array is given to us. This method returns int, which is the maximum greatness value, right? So we'll create PQ1 and PQ2 to our priority queues min heap, which are going to be holding integers, right? We have created two min heaps here. We'll be going through the nums array and we'll add all those numbers into the both priority queue, correct? This is what exactly we have seen. We'll create one counter is 0 in the beginning, and while pq2 doesn't become empty, right, we'll start processing both the queues. So we'll check if the pq1.pick is less than pq2.pick, right? So this is the case where we can rearrange them. If we can rearrange them, we are going to remove that number from priority queue 1, right? pq.poll, pq1.poll will remove it from priority queue 1, and we are also going to count it, right? Because we are actually be successfully rearrange those numbers to follow these constraints, right? Perm I is greater than nums of I. So we'll be counting it, right, in this if loop if we go inside, right? Otherwise we will just remove that number from priority queue 2, correct? So you will keep looping and you will keep checking the permutations which will maximize the greatness value here, and the count will give you the greatness value at the end. So you will return the count, right? So this is what exactly we have done actually here, right? So I just shown you step by step. So the same thing we are doing here. So we are now going to compile this code and make sure this gives us correct answer against these test cases that they have it here. So for the first test case, we are expecting 4 as the answer, and you can see that we are getting 4, which is correct answer. For the second example, we should be getting 3, and we are getting 3, which is a correct answer. Submit this code to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. it is 13.70% faster on the performance side and 99.55% on the memory usage. So these numbers are changing, so I'm not very sure about these numbers, but this is a clean priority queue mean heap based approach to solve the Leetcode popular medium complexity recent problem 2592, maximize greatness of an array. So I hope you like this Java solution today and you like this approach using priority queue as a min heap. So I'm going to add this Java code for you in my GitHub repository and give you the link of my Java codes so that you can check it out. There are lots of other programming algorithmic solutions already implemented and available there for you. Don't forget to check them out. They are very important ones. They are recently asked questions by big tech companies in their interviews. If you like the programming solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, there is a very important coding interview related playlist we have created to help your interview rounds. It is called as Leetcode and Leetcode Solutions. More than 200 most frequently asked very important coding interview problems are compiled for you under one playlist. Those problems are asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn, Netflix and many others many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them thoroughly. If you go through all those videos and problems, you are going to learn a lot about data structures, algorithms, problem solving, logic building, programming and coding. It will also help you learn lots of new techniques, lots of new ways of problem solving. So do check out the solve coding problems. The name of the playlist is Leetcode and Leetcode Solutions. Now, if you are a fresher, junior level developer and you want to practice more coding problems for your interviews, to help you when you are practicing, we have created 3 other playlists on this channel for you. The names of those playlists are Code Forces, Code Chef, and Coder. If you like this priority queue based solution where we have used the priority queues as a min heap to solve this popular Leetcode problem 2592, maximize greatness of an array, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people, so others will also be able to watch and learn from these videos. So do subscribe to this channel, share this content with your friends, your colleagues, so they will also learn problem solving and Java coding and programming. Click on the bell notification icon button right away so you will always get immediate notifications for all our upcoming interesting videos here. If you are a fresher, junior level developer and you want to learn how to solve coding problems like programming interview questions, right? Because solving programming interview problems is an important aspect of interviewing process. To help you with that, we have created lots of solve coding problems videos here that you can use to learn more data structures, algorithmic approaches. You can use them to prepare well for your coding rounds of interviews, learn more programming and coding using Java as well. The important varieties covered here that includes dynamic programming, graphs, matrices, binary search trees, binary trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are lots of other important data structures related coding interview problems also available for you here. That includes stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All are important questions. Those are selective questions asked by big tech companies in their past interviews. So we have created solutions videos here to help others also learn how to solve those problems and how to do the implementations. So make sure you check out those videos. They will give you a good preparation for your interview rounds. You are going to learn a lot of new things from this channel as well. If you are planning to take Java interviews, there are lots of Java related videos available on this channel for you. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers where they will give you database tables. They will ask you to write SQL queries where you may have to use different database concepts like inner join, outer join, left outer join, right outer join, aggregate operations, group band having clauses, different where clause conditions, MySQL important windowing and ranking functions along with partitioning. So everything is demoed with SQL database tables as well as SQL queries for you here. There are videos that discusses Unix questions also available for you here. For example, Unix commands, Unix utilities, shell scripting questions all are here for you to help you in your interview preparation and learning different computer science concepts. If you like the videos on this channel, if they are helping your learning process, you are learning more techniques, more problem solving along with programming and coding, then please do leave your feedback, messages and comments below these videos. Your feedback, your comments and your messages are highly appreciated, very important and valuable for us. They increase our motivation to create more quality content videos to help others on this channel. So do leave your messages below. Tell us how the videos are useful and helpful for you in your learning and interviews preparation. If you want us to create videos about any specific computer science, Java J2E or interview related topics, then mention those topics as well in the below's comments section box so that we can create those videos for you here. If you haven't already checked out the playlist of this channel, go to the playlist of this channel right away, check them out. The problems are categorized based on the problem types for your easier practicing purpose. All important coding questions related to varieties are available here. Those are the varieties that typically get asked in the interviews. So everything is here, so do check out all those videos. They will definitely give you a good preparation for your interview preparation process, and you are also going to see a lot of varieties of problems that typically get asked in the interviews, right? Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly keep your learning process and practicing going on continuously. And thanks for watching these videos.